What's up on Power Crew? Today's video, check it out. Got this all laid out here for you. But what is it? That is a, let's just call it an electrical upgrade to take the weight off of your fuse block, your factory fuse block. What do I mean by weight? The extra amperage. Every time you add a CB radio, you add a stereo receiver, or you add USB ports, you add another 12-volt plug for radar detectors or fancy mirrors, backup cameras, who knows what. Every time you add something else to that fuse block, either one, you run out of extra ports to plug it into, two, you add an extra amperage load to that fuse block. So this little circuit thing we're laying out here today is going to take all that pressure off of your factory fuse block and send the amperage load directly to your battery the way it should be. Therefore, your factory YJ wiring harness, it doesn't have to deal with it. The only time you use your fuse block, all you need is one accessory tab to come off your fuse block to activate the relay. Super simple. Now, are you the type of person that likes to save money? Well, we all do. So this is the channel for you, because I'll show you really cool ways to do upgrades, fix, repairs, tools, all kinds of cool stuff. So hit that subscribe button so you don't miss a single video. Alright, let's do this electrical upgrade. Now, before we get to installing all this good stuff, let's explain what's going on. Each one of these right here, obviously, are little power distribution blocks. You got your positive cable here, negative here. You've got ground and positive per block. Makes installations of accessories so much easier, because you don't have to take a ground and find a particular place underneath your dash and hook to that exact same ground every time, and you get a stack of screws or a bunch of screws or a bunch of eyelets and stuff like that stacking up under a screw, causing bad ground issues. That's just a headache. You take what I've got going on here is one of these is going to be switched, one of them is going to be full-time hot. So if you've got an accessory that requires a full-time hot, say if you want to do a USB charger for your phone and you want to be able to charge your phone with the key turned off, one of these blocks, which will be this one, is full-time hot all the time. Keys can be in my hand, this is still hot. This one will be switched, meaning when I put the key in the start, run position, I start the Jeep, whatever, or even if I just turn it in one click and it's in the run position, that will activate this block here, powering up all the fuses on this for whatever accessory, stereo, lights, whatever the case may be, just whatever you decide you want to put on that circuit. So having two different individual circuits, a full-time hot and a switched circuit, is going to make installations of electrical upgrades so much easier to deal with. And like I was mentioning about the grounds, you're going to take these two wires right here, find you a solid ground underneath the dash, make it solid, and then from that point on, here's your grounds from here. It makes life so much easier in doing installs. As you can see, each one of these right here has their own fuse. Hot line goes in here, cycles through the fuse here, boom, comes out here, and this is where you're going to tie your accessories onto, coming off these screws here. Now, how does that switch circuit work? That is such a good question. Now, here's what I've got set up. You've got this right here is going to be on your battery positive, okay? This is going directly to the battery. Battery will come through the wire here, come through my main fuse block. This main fuse block will protect the circuit of all this combined. You always want a main fuse in your circuit. Now, how big is that fuse going to be? We'll talk about that here in a moment. Okay, so battery current comes through here, comes through the first fuse here to protect the whole circuit, comes through here, hits this lug here, and notice the battery comes here, then this one comes off here. This is a high current relay, meaning high current. Most of your Bosch relays, like the 5-pin relays you plug up underneath your dash, or that you've got under your hood or something like that cars typically come out with, it's got the 5 pins. Those are only rated 30 to 40 amps, some of them are even 20 amps, but very few of them is rated above 40, but the most common is 30. This is a 120 amp monster, and you can even get bigger than that. Now, am I going to require the whole 120 amps? Absolutely not. But what I wanted is enough headroom. What headroom is, just say hypothetically, I'm pulling 30 amps on this one, 30 amps on this one, I got 60 amps total. Okay, so I got 60 amps total coming through this. Technically, all 60 amps is going to come through this. So that's going to answer the question, what size fuse do you need for this? If I've got 60 amps of pull on this right here, the fuse I put in here will probably in the ballpark around an 80 amp fuse, because you just go one step above your needed current. Even though some of you are going to call me out and say, hey Chuck, that's blue, so I mean you got 60 amp in it. Well, yeah, that's what it came with, but I've got more fuses other than just this one. So if I have 30 amp circuit on this, 30 amps on this total devices feeding off of it, does that mean that this is going to see 30, 60 come through this? Nope. Because this side here, this leg here is only seeing 30 amps because it's connecting here and then going out to the battery. This side right here is your full-time hot all the time. It's never switched. So if I got 30 amps on this one leg right here, and I'm just using 30 as an example, it may go higher, but honestly I don't plan on making it any higher. But it's coming through this post here. So what happens? This is a high current relay, like I said. Black wire here, post 86 on this. Post 86 will go to ground. So when I both mount this, I'll put me a little eye, I'm gonna cut this, I'll put a little eye loop on it, eye ring, whatever. I'll put it behind that to ground for this. This will go to magnetic switch on my fuse block. So whenever I put magnetic in run position, it'll send current or electricity to this wire here, activating post 85, which clamps this relay shut, allowing current to flow through here from this post, through this, come out this post, and power up this one. So this is nothing but a big fat monster relay. Now, I said this right here is 120 amps. It's overkill, absolute overkill. You can get them a little smaller, but again, using the hypothetical number of if I'm only pulling 30 amps through this, and this is 120 amps, I've got a crap load of headroom. Headroom is how much current you're currently pulling versus how much is it capable of handling. That difference between of how much you're pulling and how much it's able to handle is what you call headroom. Now, if I was to put a regular Bosch relay in here that's only pulling 30 amps, I'm hitting that headroom for that relay. So I wanted a relay that was well above my headroom. If I was pulling 30 amps, I want it well above that, so therefore the contacts are here and never get, it'll take a long time for the contacts to start wearing out and I need to replace the relay. But to be honest with you, I could have gotten a smaller one. Like I said, this is 120 amp. I could have probably got somewhere in the ballpark around 80 amps and been more than happy with it. But I'm very impatient. I think the smaller ones were going to be out a week shipping, and this was going to be next day. So hey, there you go. And it was only like a few bucks difference. So hey, no big deal. I'll link all this stuff. I built a web page on fixedjeeps.com to where you guys can go and see the parts I'm using and get everything you see here, so you can duplicate this in your rig. It popped out. I just got stuck. These cables are finished. You see I've got them heat shrinked and all that good fun jazz. These cables here are complete. I still got to build this one because I didn't know how long it was going to be, because going from battery to where I mount them at. You want your fuse block close to your battery. I'm talking close within, typically I feel more comfortable if you've got your main fuse within a foot or less of your battery. Alright, so now I got to build my battery cable. This right here is just scrap pieces I cut off when I built these sections here. So now I got to build my battery cable from battery all the way inside the rig. Get her done. Now in my quest to clean up all my wiring, I have pulled out all that. I no longer need it because of what we're doing today. So what I'll be doing, I'll be putting that ring, one ring around here, about 5 to 6 inches of cable, boom, mount my fuse block here, out of the fuse block into that grommet right there and into the firewall, on the other side of the firewall to hook into my relay, and so on to put all my distribution blocks in. Now, as I mentioned about cleaning up my wiring, there's a certain, I keep looking at the Expeditions in the junkyard when I get the opportunity. They've got a fuse junction block that's mounted up here that carries these mega fuses in them, but it seems like every time I see an Expedition that should have one, somebody's already got it. Because I want that right there gone. It works, it's functional, but it looks like crap. But why have I got that there? Because I've got my big fat cable running from right there all the way to my alternator. Why do I need such a fat cable? Why did I not use the factory cable? Because that's not the factory alternator. That's a 135 amp Dodge Durango alternator. that actually slings out some real juice. Whenever you do the Dodge Durango or was it the Jeep Grand Cherokee alternator upgrades that has so much more power output, upgrade that charge wire. I know there's going to be somebody blasting up in here because I see it in the Facebook groups and the forums. Well, I did that 135 amp alternator and I ain't upgraded my charge wire. It's doing just fine. Yeah, okay, fine. That's great. I'll find dandy. But here's the deal. One of these days, whenever you got your bump sound system going and you've got that thing turned up and you just driving down the road and you be bopping around, that system is pulling a ton of amps, okay? So, but you say, well, I got it hooked to the battery. Well, yeah, you got it hooked to the battery, but what charges that battery, huh? Yeah, that alternator. So if you're pulling a ton of juice from the battery because you've got your bump and sound system going, you've got all your fancy lights going, and some people who have to have their pretty little blue, greens, and reds and interior lights, and they got them on to make themselves look all cool. All that stuff adds up to power draw from your electrical system. So that alternator is the heart that charges all that stuff. You need to upgrade that charge wire. Don't do it like the factory. Come from here to here. That's a no-no. You take it from here to there. Now again, whenever I run across one in the junkyard, I'll show you guys how to do that upgrade because I'm pretty sure it's on the Expeditions that has that block that sits upon the firewall that carries this mega fuse. It looks so much more neat. So that's a video for later on down the road. So what I've got coming up here also, being that I'm running a marine style battery, I can use this post right here. It runs off that, it cycles around here, and it comes into the back of my fuse block, feeding off that. But if you've got regular battery terminals and stuff, you can get the marine style clamps, and I've got some of those in the house. I'll show you guys how to put those on sometime soon in an upcoming video. And they make life a lot easier when you start stacking multiple wires for your battery posts. So with all that good stuff being said, I'm gonna go ahead and start running my wire, my positive wire for boom to boom to right here, then out of here into the under the firewall right here, and then from there I gotta figure out where to mount my blocks. Let's get on with it. Now prepping these up in case you guys have never used them before. 4-way screwdriver, take those screws out right there. Put your hand right there, turn it upside down, boom, all that stuff falls out. Which is okay. Put it all right there, so nothing goes nowhere, theoretically. Now see that hole right there in the middle? That's our mounting hole. So what I'm going to do is put that up on my firewall, figure out where I want it and how I want to position it. I'll drill me a pilot hole, or you can use self-tapping screws, totally up to you. I'm going to drill me a little pilot hole. Got some stainless steel screws right here. Mount that baby to the firewall and I'm good to go. Now when you go to put your wiring in, and this will all be put together with the fuse in it, because you take your fuse, put that in place like that. Put your screws back in, all that fun stuff. What you're going to have is, these things will accept a couple different gauges of wires. Back that set screw out, and you see you got a sleeve right there. And if you got a small diameter wire, like I'm using 8 gauge here, I'll take that 8 gauge, I'll stick it up inside that sleeve and all goes up inside there. That way you get more copper contact to your lugs. Now if you're using like an 8 gauge, like a 6 gauge, or it'll do a 4 gauge, then you would take the lug out, stick that wire beside there. But then you feed it beside there because you got that hole right there. You need to line that up with your screw here. Stick it beside there, like that. And you'll just tighten it down with the wire in, of course. So, all right. If no one's ever used these right here, these are much better than using those glass tube looking fuses. Those glass tube looking fuses, what they do up inside, because you got a cap here and a cap here, then you've got that wire in between it. That wire is soldered to the cap on this end, on those round glass style fuses. I don't have one right now, so. But what happens, that solder sometimes gets weak up inside there, and you may be running a 10 amp fuse, but because that solder gets weak, you're actually, the 10 amp stamp on it may only, it may say rated for 10 amps, but you can only handle 8 amps because the solder link is weak. These right here, this is all one stamp piece of metal. Therefore, there's no bad links or anything like that. and when they blow their true current of 60 amps, 40 amps, 30 amps, whatever size you're using. This style fuse right here is so much better than using those glass tubes. Stay away from those glass tubes altogether. Even with, like, pan up around here, like your power distribution center, these right here are okay. The smaller plug-in ones, they're okay because that's one solid piece of wire, much like these right here inside those plug-in style fuses. So stay away from the glass tubes. If you've got one of those old school ones that, how can make me a power distribution center out of this because I already got it, trash that rascal. Buy you a real one. See that pilot hole right there? I just drilled that because what I did, I put this up next to the firewall. Says I want it to be about right there. And I drilled me a pilot hole right there. Now I run my sheet metal screw up inside there. Cool. Like I said, you can also use self-tapping screws, make life a little easier if you want. But I'm just using what I had here. Uh-oh, I hear thunder. Anyway, I better get this thing in place and make that run for a little faster because I think I'm about to get rained on. Okay, I'm going to show you guys what I'm doing to solder these lugs on. I've got this big bad boy right here. And I'll put a link. I'll build a web page on fixjeeps.com to where you guys can go. It'll be one page will have all this stuff instead of you guys having to search through all of YouTube's fun stuff. So, take your little soldering gun here, pull your trigger, let the tip heat up. Now as far as my solder, I like using the really thin stuff. This is like 0.6 millimeter. It takes quite a bit of it to fill up these lugs, but what it does do, it melts easier, and whenever you're doing small detail stuff, you'll have this as well. Now you can use a thicker gauge solder on this stuff, would not be a problem, just as long as you get it hot enough to melt with your soldering gun. So tip's heating up. I'm still holding the trigger. See where I'm at. Yes, look at that. Ooh. So what you want to do is hold on the bottom of your lug. Alright, I'm going to get something to lay on top of this right here. Lay on top of this because I'm trying to push against this lug. And when I do that, it's wanting to move my vice grips there and make it a pain in the tail. Right back. By golly, I lay a big bit. Boy gosh, I lay a big rascal on there. It ain't going nowhere. Alright, get my gun heated back up. Thunder is rolling in. Solder your tip right there. Stick it to the bottom of that. I have lots of solder ready to feed in. It goes quick. Once it gets hot enough, the solder feeds in fast. And once you get the solder melting inside the cup of the lug, don't take the heat off of it until you're ready. There it goes, starting to flow. There it goes. See, I'm filling up the cup of that lug full of solder. Pull some more out here. Notice I'm not taking the soldering iron off of it whatsoever. I'm just feeding it down inside there, and what I'm getting is a pool of solder down inside there. And again, this thin gauge stuff, it eats it up quick. That's why I got another roll right up above out of camera shot, because this roll right here is about done. Now again, if you use a thicker gauge, filling up the cup does go faster. But honestly, I used it all up building those other ones, and I don't feel like going and getting none. I want to get this done. At least with the outside circuit done, so I can outside part of the circuit, so I can run my main wire on the inside to know how long I need to make it, so I can mount my blocks. But I have got a very dark storm cloud right behind me right now. And let's see, I'm about halfway full. Notice I'm not taking the heat off of it whatsoever. And you can see the flux from the solder building up inside there as well, and that's okay, because the flux is actually about right there and solders down below the flux. I might actually have enough solder in now, so let's see what we get. Because whenever you push a wire down inside the lug, it's going to push some of that out. Feed it down slow so that it allows the solder to wick inside the wire. You see, I'm kind of forcing it down so therefore it crams it toward the bottom of that lug right there. I take the heat off of it. Hold your wire in position where you want it. That way, if you want it to cant to the side a little bit, whatever, I never do if I can prevent it. I always like to come straight out. So when I put my heat shrink on, it forms properly. There it is, all set up. Now we'll take heat shrink, wrap it till about right along in there, heat that sucker up. Y'all hear that thunder? I'm about to get wet. I gotta hurry. Now this end of the wire is going to go up inside the fuse block. So all thing I need to do is really strip my wire back to about right there, cram it up inside the fuse block and tighten down that hex head screw, and that'll take care of this end. You can, and it's actually advisable, if you want to strip this back and wick some solder up inside the copper, it actually gets a better bond with the set screw. So yeah, I probably got time for that. Again, I'm watching this cloud rolling behind me. I'll give you guys a quick look as to the way I did this. You see me solder the lug on, put the solder inside there. Heat shrink, I got 2 steps of heat shrink. You can see right there the first edge that I went from here to there, get around that edge right there. Then I went a longer piece, that also from here to there to overlap this, and make it as waterproof as possible. Then I heat shrink this right here all the way up inside there, but I also kept it exposed to where my set screw bites onto the copper. But I did solder it. I did it off camera because again I'm trying to outrun the storm or get something done. But I soldered the wire together, soldered the big lug, make it one piece so it doesn't spread when I tighten this right here, and it bites into that solder, makes a good solid connection. Then I did the heat shrink here to make it look all nice, neat and tidy, and there you go, get that installed. And there you go, I've got it hooked to my battery terminal. It's all tightened down. I've got it going into this lug right here. I've got that tightened down, and of course this right here is just hanging loose until I go from here to through the grommet into the firewall. Now, one word of caution, yes, somebody's gonna say, well, I can go ahead and stick my fuse in, but as soon as you stick that fuse in, you're making this lug right here active, and if I put my wire in and run through the firewall, that's gonna make that wire active. Don't put your fuse in until you're finished with the project, okay? That will prevent you from doing an oops and shorting your wire out and causing something to burn up or just causing sparks and make you jump scared, whatever the case may be. But don't put your fuse in until you're completed the project, okay? Okay. Where I'm going to feed the wire through is right here. Come down, see the gas pedal here, come straight up, right there. Do you see it yet? Right there. Grab hold of it, pull it on through, then we're going to feed it over to the block. Now, as you pull your wire through, just pay attention to how this wire here is coiled up in the floor so it don't become a jumbled mess on you. And you can see I've got the wire pulled through. It's just kind of hanging in the block over there at the moment. If I pulled it out, brought it up, come over top of the main harness here, so therefore you can tuck it in behind the main harness all the way through here and just kind of zip tie it, or get you some more of that tubing like this right here, wrap it around that to make it blend in real well. And right there it is. So I'm going to go lock her in. So take your block, there's your sleeve, tuck it in there. It's a lot easier if I watch what I'm doing instead of watching the viewfinder. Okay, now we got that set in place. Take this, feed it into the end of the block, and then tighten up your set screw. Don't have to get crazy tight. You just want to be sure that you can't pull this wire out, but you don't want it crazy tight, okay? Okay, I've got the wire locked in real well. Of course, I don't have the fuse in because remember what I said, we're not putting the fuse in until we're done because you don't want to short nothing out. But look, it's just floppy hanging in there. So what you can do is now tuck it over top of your harness, take your wire ties and tie it in place all the way over top of the harness. And once you get over there, you'll have that loop hanging down. Then simply get inside the Jeep, pull the wire coming through the firewall, and you can tighten that loop up and make it look all nice and pretty. Just go ahead and put the cover on until I finish up everything on the inside. Then I'll pull the cover back off and put the fuse across it, and we'll be hot and active. But I got to finish everything on that side of the firewall now. Depending on where you got to mount it, you may have to work with your lugs a little bit, bend in shape, stuff like that. You see I bent that one upward. Then I kicked my wire, bent my wire upward. Well, I say up, bent upward from the surface of this. This is actually going up at the dash because it's being mounted like this. And so once I get it mounted, I'll show you why I had to do what I did. I wanted my ground on this side because of where I'm putting my ground location. And I'm hoping, because I pre-built my leads here, I'm hoping it's still going to work out for me. I'll find out once I get them both in. Now I've got the wire pulled through and kind of trimmed off. I've got plenty of excess here to determine my length I need to tie into these, or tie into the relay actually. So with these, I put in with these sheet metal screws. Okay, it works pretty good. You can see right here where I've got the holes. I drilled pilot holes. Where's my fuse block? Well, basically what I did is I took my fuse block, held it up, and said, yeah, that's about where I went at. And drilled me some took my drill bit, marked where my hole locations were, then pulled the fuse block out, drilled my holes appropriately, then put my sheet metal screws in. It works, but here is the downside to it. Look real close, right there. You see the sheet metal screws actually coming through the firewall. Now, is that really a big deal? Nah, technically no. But your crankshaft position sensor is right down below that. Say, for instance, you want to change that crankshaft position sensor. You've got those pointy little screws sticking out. Well, you can imagine the cuts you can get from that. So here's what I'm going to do. Rivnuts. These things are here are awesome. Since I've already got my holes pre-drilled here, all I got to do is take a bigger bit, knock those holes a little bit bigger, pop these in, and I'm good to go. This is a 1024. I'd prefer an 832, but the thing of it is, I don't have a die for my Rivnut tool to put in the smaller one. So I'm going to take the 10s, and I take that drill bit right there, drill those holes open just a little bit more. That allows the 10 to go through the hole, like so. And see, even though it's a tapered head screw, it sits right there just nice flush as it can be. Works out just perfect. Now, just because I mounted them there doesn't mean you have to mount them there. You figure out where you want to mount them, totally up to you. I'm going to give you guys a little Easter egg hint here, because eventually this whole dash is coming out, and I'm going to do a CJ conversion. It's not anytime soon. I'm still gathering parts right now, but it's going to happen. So whenever I do the CJ conversion on this dash, then I'll take and move things around the other ways. Now that's again one of the advantages to using zerk nuts or Rivnuts, whatever. I don't know why I keep calling zerk nuts. Rivnuts is that any kind of holes you may have in the dash, you simply put a bolt inside there and plug it up, versus having drilled holes like that with sheet metal screws, and you end up having to put another screw inside there, break it off, or weld them, or whatever the case may be. Totally up to you. Now, one thing I will say, right there, right below your fuse block, is a beautiful place to mount it, because it's nice and flat, plenty of space to work with. But there is one major catch-22 right there. What is that? Now I want you to pay attention to something. Right, look at the viewfinder if I can see them. Okay, that's a ground point I put in right above that. See that spot? See that spot? Let's go to the other side of the firewall and I'll show you what that is. Because if you mess up right there, you could kill your Jeep dead. Those little plastic things I pointed at is right there, and the other one is back here. Where's my finger at? There it is, right back here. So what those are, what that is the ECM for your computer. That's your computer's brain right there. So if you were to drill pilot holes through that firewall on that other side, you are very subject to drill right through your computer. Don't do that. That would be bad. So I'm going to finish drilling out my holes for my Rivnuts so I can put the bolts in place. And I'm also going to use one of the Rivnut locations for my ground for this right here. So next time you see this, that will be done. I've got two of the Rivnuts in place, you see here and here. The only reason I don't have them up there is because, well, I don't plan to pull my dash apart to get my drill up inside there and get the Rivnut tool up inside there. So yeah, there's that. But you can see how flush that sets with those, very nice. Now I'll show you something on the other side of the firewall, the difference between the screw stick out and the rib nuts. You see the rib nut right there, and right there is your screw sticking out. Obviously the screws will be the one that'll hurt you the worst. The rib nuts, they stick out a little bit, not too bad, but you can also get a shorter screw and just shorten that up a little bit. The thing about the rib nuts and using the screws, I'm using a 1024. It's not going to eat them hands up like those screws will. Also, another way to take care of those screws is get your Dremel tool that's got the little cut-off heads on it. Zip them things off, cut them off kind of flush with the firewall. It'll prevent the things from coming out and biting you. The other mounting possibilities would be if you was to have like a little platform underneath your seat, and especially if you got like a power amp for your sound system. You can use all that as like a little fuse block area to power distribution center or something like that. That'd work underneath your seat. Also, you could probably make your panel to go up underneath your dash. That way you wouldn't have to penetrate through the firewall or anything. Let's see, passenger side, your air box is in the way. You could probably do something inside your glove box if you wanted to take out the space there. So you're gonna have choices as to where you want to put them. And also, if you guys got any recommendations where it would be a good place to mount something like that, you can drop them down in the comments. I'm cool with that. You might actually have to talk me into changing the location on mine. You never know. Now it's time to set up our high amperage relay. These two posts right here, one's going to be ground, one's going to be to your ignition hot. So whenever you turn the key on, it'll activate this side of the relay, which, see, 85, it'll be this side of the relay because 86 is your ground. 85, it'll activate 85, 86 is your ground. It'll clamp the coil inside here, so as your battery's coming in one side, and it clamps the coil on the inside, it'll circle out this side and your side. Pretty easy install. Did you know there's a right and a wrong way to crimp terminals on wire? See, I've got my indention there. Come to the back side. Right there's the split in the terminal where they take and wrap it around. That's actually, I pulled the insulation piece off of this one because it started out life like this, and I pulled the yellow one off, the yellow terminal insulation piece, because I'm using heat shrink on it. But what I do is the split side here. If you look at your crimpers, you got the trough here, and then you got the little pointy, spiky thing right here. Your split in your terminal right there goes down inside the trough here. Then your little nub right there, whenever you crimp it down, make sure indentation there, but it does not spread the split, because if you take it the other way around, use the little nub and push down on the split, oftentimes it just kind of opens up the terminal and it doesn't crimp tight as it should. So always pay attention. There's your split, which is normally on the back side of your connector, like you see here. Put that down inside the trough of your crimpers, and the little nub right here goes on the top. Crimp her down good. Now I'm going to do this heat shrink. Got everything underneath the dash wired up. I just got to tidy it up, but we're going to put a fuse in and give it a test. Now, sometimes you put this fuse in, it won't fit because you try to cram it back in there. Remember, these blocks come out, so they'll slide back and forth a little bit, which is actually also a kind of a bonus for you, because sometimes you'll put that fuse in and you'll try to hold it in place, get your screw, and try to be a contortionist because you're trying to hold the screw in place and hold this in place at the same time. The screw falls off the screwdriver, all that chaos. You don't want all that. So put your screw in, take your lug, push that wire inward like that. It'll hold that fuse in place for you. That way you get the screw started. We can use the high-tech meter to test our voltage, or we can use that. I'll show you what this comes from here in a moment, but first of all, let's test this right here. So I've got my relay still hanging here so I can demonstrate to you what's going on. Okay, so we got on this one post right here, on this one side, I've got this wire right here. This one right here comes directly from the battery. Remember the one we put the fuse on outside under the hood? This one is going to that block right there. Then this wire here is going to that block right there. Remember what I told you? Because one of them's going to be a full-time hot, the other one's going to be switched hot. Meaning when I turn the ignition switch on, it activates the block. So that one right there is full-time hot right now, which means the key does not have to be on. The keys can be in your pocket, it don't matter. Matter of fact, there's my keys right there. So what have I got? Ta-da! 12.5 volts. So are we ready to test this one right here? Well, of course we are. So we got this one right here. That's our ground. Leave it in place because grounds are common. Remember, we got joint here. Short, grounded out here. Then we got the lug from this one jumping down to this one, making it all the grounds one common block. So now what we're going to do is take this loose, because that's our going to our little digital readout. We'll put this there. And what do we got? Ta-da! Nothing. All right. See, there's my keys. Let's grab my keys quick. Grab my keys. Put the keys in the ignition. Turn the key on. Boom. We got voltage. Super simple. So now we got one side, whenever you turn the key on, it activates that block. The other side is hot all the time, so if you want to run your USB, like battery, phone charge or something like that, you don't want to have your key on, you can do that now. Set it up however the heck you want to. So what port did I use to be able to trigger that relay? It's right there. See the heat shrink red wire, the blue heat shrink on the radio port? That right there, till I turn on the key, it activates hot. When I turn off the key, it's not hot, it turns off. So that's what I'm using to trip my relay with. I told you guys I would tell you what this came out of. It came out of one of these. This has like the 12 volt accessory, or in some cases it'd be a cigarette lighter, but it wouldn't work for a cigarette lighter because, well, I don't smoke anyway, so therefore it's pointless for me. But like your radar detectors or your, like where I've got the mirror in this thing, you can plug that in there and have power for it. Then this piece right here was actually in the end of this right here, but I didn't care nothing about having that. I wanted the extra USB plugs. So I bought another one of these, plugged it in there, so therefore I would have 4 USB ports so I could charge, phones, the batteries for my camera here. I've got the battery charger for it will actually charge off of USB as well. So if I am out someplace and I need to keep extra batteries, I can plug into this thing, keep my batteries charged up and keep rotating them out, and I can keep on the footage. So basically you can, I'll link these up down to Amazon to where you guys can see different configurations. You can build them however you want to. When I install this, what my plans are is this one's going to be switched on the switch side. This one is going to be on the full-time hot side. Why? Because the full-time, this right here has no LEDs built into it showing that it's on or whatever. This right here has that little ring right there that's going to light up whenever it gets power. So with having, not that LEDs pull a lot of power or anything, but it's just one less thing that's going to be pulling all the battery out of full-time basis. If I wire this one to the switch side and this one to the full-time hot, and this right here is going to be, I'm thinking I'm going to put a switch also. So probably what I'll do is I'll jumper these two right here together, run them off of one wire, this right, and run it to the switch side. This right here will go to the full-time hot block. And this thing right here, I just turn it into a little test probe, I guess. Yep. And once you get everything wired up, you can go ahead and snap your covers in place. You see right here, there's the tabs. They go on the ground side over here because you can feel the little bump right there where these hook into. So snap these in place, so therefore it makes it nice and pretty and prevents any kind of electrical shorts too. So get those snapped in place. I just thought of something. I snapped that cover on. I thought, I bet you somebody's going to say, well, ain't that going to get in the way of your gas pedal? Well, no, it ain't. But look, it ain't even touching. If I push back on it, it's touching. But the thing of it is, when you push on your gas here, zoom back a little bit. When you push on your gas, it actually comes away from the fuse block. See? So, and when I turn loose of it, it's not even touching the block. So it's all good. But appreciate your concern, really do. Yes. Now, I really would have liked to have a different mounting area for it, but I wasn't planning on ripping my dash apart just to put those in, at least not at the moment. I've got the CJ, I mentioned a couple times, the CJ dash conversion. I've also got some speakers, amps, and stuff like that. Eventually, I'm gonna put a real sound system and things so I can actually, have some real good tunes. Right now, I just got the radio and the soundbar speakers. It sounds okay, but I don't know. I'm more of an audiophile. I like a good bottom end bass. I like a good, solid, clean sound. So I don't listen to the radio much because every time I turn it on, it sounds like it's singing in a tin can. Yeah. So with the upgrades I'm going to be putting into it, putting those blocks in is going to help out a lot for expansion. I've got some really cool lights I'll put in here for both like interior lighting and I don't know, because ambiance lights, because I got some red, got some blue, RBG LED type strips. Those will be going in as well. I showed you the little USB port things. They're going to be going in my dash. So that's what those blocks are for. And after you add all that kind of stuff to your factory fuse block, you run out of ports to plug into. Also, you keep loading and loading on those ports, well, eventually you're going to exceed, you possibly could exceed the amperage of that particular circuit, which would turn out to be a bad thing. So those blocks could come in handy. So if you enjoyed that video, hit me with a thumbs up, subscribe if you haven't, leave me some cool comments down below. I appreciate you hanging out with me. Peace. Later up. Later y'all. Yeah, that's it. Later.